Yeah, okay, guys. So, welcome to the Robotics and Artificial Intelligence meetup number 60. And in today's meetup, we have a very special guest, Sina from the channel Robotics with Sina, and he'll be talking about how to start learning robotics. And he'll be giving a roadmap on how you can start learning robotics as a beginner. Sina is a surgical robotic software engineer, and has been involved in robotics for several years. He also has a PhD in this area. So it would be really interesting to get to know his views on how to start learning robotics. And the agenda would be such that after this introductory presentation, we'll have a discussion. So I think this is the agenda is I didn't update basically, but the main thing is that after my introductory presentation, I'll hand it over to Sina, who will be doing a 30 minutes presentation, which would be followed by a question and answer session. So, talking a bit about the community, what we do here is basically we are solving the problem that there are too many resources that are existing already in robotics and AI, and people don't know where to start. And that is why the theme for today's session would also be very relevant, right? So I'll not talk about these things in details, but the main idea is we are trying to find and share with you the best ways to start learning and implementing several fields in robotics and AI. And we do weekly meetups and also podcasts. So yeah, let's just start. And after that, at the end of the session, I'll also talk about what we have been doing with creating the accountability, creating the volunteer team. And some of the people have been very active in the Discord server, but these things we'll discuss after today's event. So let's get started. Over to you, Sina.
Sure, absolutely. Hi, everyone. Thank you for joining us today. And I almost do not recognize a lot of faces here or usernames. I thought more people from my channel will join, but probably they don't like me that much because I talk a lot. So, but but thank you all for joining. I think today will be a very informative session, and thank you, Sync, for having me on your Discord server today. And so to start, I think you gave a short like description of who I am, introduction of who I am, but I'm gonna go through the two slides I have quickly. So I'm a surgical robotics engineer. During the day, I have a PhD in surgical robotics, and not I don't build the robot that Michael Reeves showed on that video. So that was a joke, but I'm a serious, real life surgical robotics engineer. I work for Striker Robotics. It's probably the second largest surgical robotics company in the world. I do a lot of algorithms. So I transition from robotics mechanical engineering to robotics software engineering, and I'll encourage everyone to do so. We'll talk about it in a little bit. But so that's my professional background. And at nights or during weekends, I'm a content creator. I create a lot of contents around how to become a robotics engineer. I'm on YouTube, I'm on LinkedIn. I just recently started on LinkedIn. And I try to give people like roadmaps, guidelines, how to start, answer their questions, do a lot of QAs. I mentor people. And yeah, so if you're looking for a mentor and you're serious about it, just don't be shy. Reach out to me. I'll be more than happy to be your mentor. All right, so next slide is, so I just put a couple of projects, more than a couple, yeah, maybe 4 or 5 projects that I have worked on since I started my PhD program back in 2011. I know it's a long time, but I'm not that old. But uh, so uh, so recently, as I said, I'm a surgical robotics engineer with a Striker. This is a picture of that robot that we currently have in the market. And then before that, I worked for a consulting firm who was involved in development of this robot, which is a spine robot for spinal surgeries. And then this robot was, and I was a small member of the team. I'm not claiming I did everything. So I was a small member of the team. It was a small team and we had like hardware and software engineers, test engineers, and mechanical, electrical, software. And then I wore different hats and was part of a team. I did a lot of different things. I did a little bit of kinematics. I developed a couple of C++ libraries for the tool tracking, like basically surgical tool trackings. And I did a lot of testing on the GUI, the spine, surgery procedures, and everything around that. And before that, during my PhD, I worked on two robots basically. One of them here was a robot for colonoscopy. It was a soft robot that will go from the beginning of intestine to the end autonomously with really like non-invasively. So the goal was it's much less invasive than the current methods. And the other one was with another PhD student. We worked together to design and build and test this robot, which was basically a snake robot for natural orifice surgery and was basically responsible for the arm, not this arm. So we developed two arms. One of them was all electric, like using electric motors. The other one was hydraulic or pneumatics. And this tips like the very last link of the robot was supposed to basically be multifunctional, just be able to like carry different tools for the surgery, so the surgeon doesn't have to pull the robot out and replace the tool. So that's the two projects I worked on during my. Uh, we have a lot of background noise. Okay, that's good now. All right, so now let's get to the good part. So a lot of you guys have reached out to me in the past and you wanted to know how to start to become a robotics engineer. So if you're still in college, if you're pursuing your bachelor's or even your master's or PhD, you still have plenty of time to pick up the necessary skills and end up becoming a robotics engineer. But if you're early in your study, I would say there are different majors you can pick that will produce basically a robotics engineer. And those are computer science or computer engineering, mechanical engineering, electrical engineering. Some colleges they offer mechatronics for undergrad, but I haven't seen many of those colleges, but there are some that do offer mechatronics. So if your college offers that, just definitely you can major in mechatronics. And robotics, there are not that many universities or colleges that offer robotics program for undergrad, but usually there are some that I know there's one that is very famous in the US that offer a lot of online master's programs. WPI, they do offer a master's program in robotics, and all of the courses you take, basically all robotics, right? And but if they do not, what you can do is you can pursue a master's or PhD in any of these top three, like computer science, computer engineering, mechanical, electrical, and just make sure that you do your project, your thesis or dissertation in robotics. So just pick a project that is relevant to robotics and work on that, and then pick up the skills, and then chances are you'll have the skills that necessary to land a job in the robotics industry. But many of people have reached out to me to say, hey, I have options between computer science and mechanical engineering. Which one do I pick? And I have a video on that one that I say mechanical engineering is dead. And I know some of you might be mechanical engineers here, but it's just the fact, right? It's just pure mechanical engineering is just, I don't know, like designing a pressure vessel or stuff like that. If you want to work on the high tech side of the industry, that's dead. You don't want to spend your time and energy there, right? So, and like my background is mechanical. I think what is your background, Think?
My background is a robotics engineer actually. So my master's program was exactly called robotic systems engineering.
Awesome. But your bachelor's was what?
Bachelor's was in mechatronics. Yeah.
Mechatronics. Awesome. Yeah. So the reason for this is, again, if you're early in your study and if you're good at math and programming, definitely go with computer science. No doubt. You'll just do it. You'll thank me later. The reason is like a lot of innovations that are happening around like tech is basically all computer science, right? It's not really mechanical engineering. Look at self-driving cars, look at surgical robotics, look at uh, all the other stuff that we're very excited about, like AR, VR, metaverse, I don't know, you name it, they're all computer science related. They're not really mechanical engineering related, right? Even surgical robotics or self-driving cars, the challenge is not in the mechanical side. There are still challenges, don't get me wrong, there's still plenty of challenges in that area, but if you compare the algorithm side, the computer science side with the mechanical side, you see that the true challenges, like self-driving cars, the true challenge is not the car itself. It's all around AI, machine learning, computer vision, navigation, control, you name it, right? It's basically all algorithm based, right? And the same thing on the other side, like surgical robotics. It's like the stuff we do. The main challenge is in the algorithm side, not truly in the hardware side. So if you have a choice between mechanical engineering, electrical engineering, or computer science, definitely go with computer science. That's my recommendation and my own experience. Again, my background was mechanical, and I got my PhD in surgical robotics, but there were a lot of mechanical engineering stuff to it. And then my first job, as I said, was a mixture of different things. And after that, my second job, I was a robotics mechanical engineer for 2 years, and then a transition to robotics software engineer, which is, I think, a very good decision I made back then. All right, so now what do you do or how do you start if you're an absolute beginner? Like you have no prior knowledge of, let's say, programming, no prior knowledge of electronics whatsoever. So the question is, how do you even start? Like there are a lot of resources out there, there are a lot of YouTube channels out there, there are a lot of courses, online courses, books, which is sometimes overwhelming, right? You don't know where to start. So I do have a video on that one, but I'm gonna briefly touch on the main steps that you can take to get started with robotics. That's not to say that you will become a robotics engineer if you take these steps, but that's just to say that if you take these three steps that I'm gonna lay out right now, uh, you like you'll get it started. So you'll have exposure to robotics. You'll know the very basics, the bare minimum, and you'll be able to do some projects. Maybe if you can pursue it, if your goal is to pursue it as a hobby, that would be a perfect video for you. The steps I lay out here. So basically, the first thing you need to learn is a programming language, right? And many of you may already know a programming language, but for the sake of this, like for the sake of being able to build stuff, you need to learn C. If you already know Python, that's good. But again, if you're an absolute beginner, then start learning C. C is pretty simple. It's not complex. You don't even need really to learn all the complex stuff, like the advanced topics, just the very basics. To learn C, you can learn it in like 2 weeks if you spend like 2 hours a day, right? If you want to spend 1 hour a day, then you can pick it up in like 1 month. And then right after that, what you want to do is buy an Arduino kit and then start learning electronics. So what is Arduino? Arduino is basically a very easy to use design for absolute beginners. So again, Arduino has been designed for people who have no prior background in electronics whatsoever. So don't be concerned. It has been designed for beginners. So pick up one Arduino board. Just go to Amazon, or if you're in different country, go to, I don't know, like whatever website or online e-commerce you use to buy electronics. It's probably there. But I have resources in my videos in the description box that you can go to. I listed different resources for even different countries that you can pick up one of those Arduino kits. In the US, if it's an advanced kit that comes with all the electronics like motors, sensors, wires, and everything, you're looking around like $30. But other parts of the world, you probably spend $10 US dollars and you can get a really good kit. And so there are online resources, there are books, there are like free resources on YouTube that you can just follow and learn how to do some really simple projects at the beginning. Like, I don't know, you want to turn on or off an LED using a computer, or you want to build like traffic light, like that, then just turn it on and off, right? Very simple stuff like that. You can start with this, and then you can do more advanced projects such as a 3D printer. You can basically design and build a 3D printer using an Arduino, right? And Arduino is again is very popular amongst hobbyists and makers, and this is something I we are still using in the industry. Don't get me wrong. We use it for like building test fixtures, for rapid prototyping ideas. If you have an idea, you can quickly use an Arduino board and rapid prototype it and then show it to the team, the proof of concepts, right? So it's a very powerful tool. It's very cheap. It's easy to use. So second step, again, Arduino. Third step, you can buy one of those robot kits that is basically Arduino-based robot kits, such as those line following robot kit. Why is that a good option? Because first of all, it's Arduino based. So and then you learn C plus plus C. I'm sorry, C. So you know C. You know how to use Arduino. You know electronics using Arduino. So now you can understand everything that goes under the hood of that robot kit. So get that kit and start programming it, start doing different things. You can even add a camera to it and then do computer vision projects with it, right? So you can start with robotics, just 3 steps. And I promise you, if you spend like 2 hours a day in 3 months, in 2 or 3 months, you can get started with robotics. You can do some very simple projects that will motivate you to do more, right? And then you get started. You get started. You learn a lot of basics concepts, and believe me, a lot of times it's just the basic concepts that you need to know, not really advanced topics. All right, so that's for people who are new to robotics, know nothing, no prior knowledge, nothing, and then they want to get it started, and they want to get it started quickly, right? They don't want to spend like a year or so. They want to just spend a few hours a day, and in 2 months they want to be able to build a simple project. That's a perfect recipe. And this video has been viewed on YouTube for almost 300,000 times. So I believe people, and I have examples after examples with people who did not know anything about robotics, just followed the steps in this video, and they were able to build a cool project. I have some pictures of those projects in my Discord, some videos of those projects in my Instagram page.
Okay.
So it's proof of basically that these steps work. All right. So next is all right. So if you're more advanced now, you have exposure to robotics. Maybe you have built some projects in the past. Maybe you're a mechatronics engineer. Now the question is, okay, so what programming languages are used in the industry so that I can pick them up or become really good at them so that increase my chances of getting a job in the industry? So the number one is C++, especially if you're serious about robotics software engineering. That's the language you must know. I looked at it's basically based on my professional experience. I worked on two real life industrial robots that like one of them was cleared by FDA, and the other one is just like my current job. I'm doing a lot of C++, and so it's really a must know language. And then if you want to become a self-driving car engineer, that's a must. I looked at 2 nano degree programs that Udacity offers, and then both they do highly recommend that you learn C++. I looked at many job openings, and they have like many job openings for robotic software engineers. They have C++ as a must. I talked to a senior robotic software engineer at iRobot, the company who makes vacuum robots. He said C++ is a must. I talked to Ricardo Telez, who wrote 4 books on ROS. And again, he said C++ is a must. So if you want to become a robotics software engineer, C++ is the first language, and it's the production code language. So all the codes that goes into production, it's all written in C++. The number 2 is Python. So Python is, as you all know, is comes with a lot of libraries. So anything you can think of, Python has a library for it, right? So that's why it's used a lot in rapid prototyping. So if in the industry, if you have one idea, we want to quickly prototype it, or even if it's just the very beginning of the project, we don't know if that will, if we don't know if the idea or the algorithm we're trying to develop will actually produce good results. So we just do it on Python because it takes much less time coding, right? Because a lot of libraries are already available for you, and Sync can probably confirm that. But so that's the reason we use it, because less coding is needed, because it has a lot of libraries already available. But after you show proof of concept, after you show that, okay, my algorithm works or the idea is working in Python, now is the time to translate that in C++, which is the production code. And the third language is MATLAB. The reason for MATLAB is really good when it comes to metrics and vector operations, right? And that's the main reason people use it, because it's super easy and very powerful. It has a lot of toolboxes, again, that you can use for, like, it has a robotics toolbox that comes with all the inverse kinematics and forward kinematics equations and things that you need, right? It has like control toolbox that you can use. It has Simulink. So that's the other reason. It's mainly used for the research phase or testing or simulation. So for people who are more in those roles, MATLAB is a great tool. And so, yeah, so to summarize, learn C++, Python, and if you have time, you may want to learn MATLAB. And these are for robotics software engineers, right? If you want to become a robotics mechanical engineer, I would say just learn C and MATLAB. If you want to become a robotics electrical engineer, learn C, C++, just the basics. You don't want to get deep into C++ and maybe MATLAB. But if you want to become a robotics software engineer, these three, like the first two, C++, Python, are must, and MATLAB is nice to know. All right, so now what skills do you need to learn if you want to become a robotics mechanical engineer? I have a comprehensive roadmap on my YouTube channel. So if you want to go through the details with all the resources, all the books, online resources, online courses, everything, you want to go and check out my video. It's a comprehensive roadmap. And if you have time, that's like what you want to pursue or what you want to follow, like all the steps. If you have maybe a year of time or 2 years, or you're still in the school and you want to know what courses you need to take, just follow those steps. I promise you, if you learn those skills, you'll be golden. But just to highlight, I want to highlight a couple of them for mechanical engineers. I'm not going to go through the entire roadmap because the video is there. You can just go there and watch it, right? But as a mechanical engineer, other than the skills that mechanical engineers have, like you need to know SolidWorks so that you can do 3D modeling and design and sketches, right? So that's obviously a must know skill. But other than that, mechatronics is a must. You must know mechatronics as a robotics mechanical engineer. You definitely need to know programming languages, as I said. You also want to know kinematics. If your goal is to join, for example, a company who makes robot arms, or Tesla, you want to join Tesla as a robotics engineer, but not the self-driving car, just the manufacturing robotics engineer. You definitely deal with a lot of robot arm, right? So you want to know kinematics, forward kinematics, inverse kinematics, and rigid body motion, or something that we call it coordinate system transformation. Coordinate system transformation is a must if you want to become a robotics mechanical engineer, because that's used a lot in the robotics industry, right? And again, you don't want to get deep into very detailed, but I'm just telling you, forward kinematics is a must. Inverse kinematics is nice to know. And coordinate system transformation or rigid body motion is definitely a must. And then control is another skill that you want to pick up. And then again, but if you're taking a course on control, they're going to teach you a lot of theory. Believe me, I've taken 2 control courses, one undergrad, one grad. And then just the theory is not helping you much. The only thing that is used, like not the only thing, that the controller that is used a lot in the industry, like maybe 90% of the time, is PID controller. You want to master PID controller and forget about all the theory that you learn in the course. Just learn PID, and it doesn't take too much time. It probably spend a couple of days. You understand everything about PID. You can do a project with it. The project I would suggest, if you have time or you're still in school, would be to build a self-balancing robot. And then with that, you fully understand what the PID is. And then also, if you're interviewing for a robotics mechanical engineering, or even like software or electrical, chances are you'll get you'll get a lot of questions on PID controllers. So make sure you understand PID controllers very well. I have courses, online courses, books, and other resources under in the inbox on the description box of that video, so you can check that out. So mechatronics, control, and kinematics. If you have time, you may want to get into computer vision, but not too detailed. Just the basics. For mechanical engineers, you just want to know the very basics of computer vision, and that's probably the core three skills that you want to pick up. Right. So what if you want to become an electrical engineer, right? So robotics electrical engineers, they're basically responsible for selecting different like sensors for the robot and different actuators for the robot. So you guys basically design or select the muscles for the robot, right? So you want to be really good at sensors. You want to really be good at designing PCBs and circuit boards, and you want to know different types of electric motors and how to control them, right? How to write firmware for them. So these are the core skills for an electrical engineers. Again, a programming language, C is a must because C is the language to talk to low-level electronics like sensors, motors, stuff like that. It's all C and C++. So, but again, C++ is just the basic. You don't want to go deep into C++. So that's a must. On top of it, mechatronics is a must. But if you're an electrical engineer, chances are you already know mechatronics. So, but then sensors, you want to be really good at sensors, motors, electric motors, control. You want to be able to like write a controller for a motor, and a little bit of computer vision again, and signal processing and image processing is also a must. Chances are the signals that you're receiving from, for example, your camera or other sensors from your robot, it's going to be noisy and you're going to have to process it, right? So all of these require signal processing. And both computer vision or image processing and signal processing also a must for robotics electrical engineers. All right, so we're running out of time, but I have two more slides and we'll be done. Robotic software engineering, this is my favorite topic and something that is very hot right now. It's trendy, hot. The opportunity is there, especially in the US. If you know the skills that I basically listed in that video, you're gonna be high demand. It's gonna be easy for you to land a job because again, a lot of self-driving car companies, and not even just automakers. Like look at Samsung, look at Intel, look at Nvidia. Those companies are not automakers, but they do hire a lot of self-driving car engineers, and the majority are robotics software engineers, right? So the market is high, the pay is really good and nice, and probably that's what most people care about. It's just the pay is truly high in the US, and so, but what are the core skills? On like if you're already like a computer engineer or a software developer or web developer, you probably have some of those like math and algebra and algorithms, like the core skills that a software engineer needs. But I don't want to spend too much time. Again, the roadmap I have on my YouTube channel is one of the most comprehensive roadmaps that you will find online, right? And it just lists all the. Again, it's a comprehensive, but I'm just gonna mention maybe 3 or 4 of them. So, and think, correct me if I'm wrong here, but again, C++ is a must. And then you need to be good at math as well. So if you're not good at math, just forget about software engineering and robotic software engineering. You can be a software engineer developing web or web applications or I don't know other stuff. But when it comes to robotics and AI, you need to be really good at math. And when it comes to math, it's algebra and statistics. Like you really need to be good at algebra and statistics. And then C++, again, programming language, C++ is a must. Then it comes to core skills of robotics engineers. So Linux, definitely, again, if you're a robotics software engineer, you should know Linux. So I'm not concerned there, and that's a must as well, because a lot of robotics projects are developed or run on Linux. So that's something to keep in mind. Computer vision. again, it's one of those core skills you must know. And then if you take a computer vision course, chances are you'll learn a little bit of machine learning and AI. Usually, computer vision courses, they do have maybe one chapter or one big lessons on AI or machine learning. And so that's a must. Then Islam, like simultaneous localization and mapping. Like mapping, localization, it's used for mobile robots, it's used for self-driving cars, it's used in surgical robotics, it's used almost anywhere that a software engineer is needed, right? And then a lot of time you deal with point clouds, like you have point clouds here, you have point clouds there, different coordinate system. You need to know like kinematics, like you need to know what we call it coordinate system transformation or rigid body motion to be able to come up with a mathematical relationship between these two different coordinate systems. So that's another skill that you want to pick up, and then it's usually either taught in the kinematic course or computer graphics course, or sometimes computer vision course, right? So Islam, computer vision, and what else? And like PID controllers, again, you as a software engineer, you do not really need to get into the details of it, but you need to know the concept because chances are, again, if you're a robotics software engineer, like developing algorithms for robot arms or even self-driving cars, you need to know PID controllers. So that's another one. Kinematics, again, if you're dealing with a robot arm, kinematics would be nice to know. But the main topic in kinematics that software engineers use is rigid body motion or coordinate system transformation. If you're dealing with a robot arm, you need kinematics and inverse forward and inverse kinematics. If you're not dealing with a robot arm, you may not need those skills or those concepts. To know those concepts. And then the last thing that no matter if you want to become a robotic software engineer or just a software engineer is just to know what we call it software development lifecycle. And that's something that is used in medical device companies, surgical robotics, or self-driving cars, or even any, like almost any software development company, right? And it starts with like user needs, and you basically define the requirements, like what are the requirements for the product that you're developing, and then it goes to documentation uh, for your product, and then it gets to testing. Like they have unit tests, you have system tests, you have integration tests, so different tests that you use, different tools that you use. Like you use Jira and other tools that you use. You also need to know definitely software control version like Git or other tools that are out there for software control. And yeah, so basically testing is also a big part of any software development job. So that's something that you need to master. And if you're new, again, I have a course. Udacity offers a very good course, which is free, I believe. If you take that course, you'll be good for at least to start. And a lot of companies, like a lot of questions you will get asked in the interview process, will be around like what we call it software development lifecycle. All right. So, but last question is that I get from many people. There are people who are already professional engineers, like software engineers, mechanical, electrical, civil engineers, and they don't have time, like a student, to go through all of these skills. They want something quick and the guaranteed. Like they wanna spend because again, there's robotics. They're professional engineers, so they have maybe maybe a couple of $100 to spare, and then they don't have that much time, but they have a little bit of money to spend. So what they can do is to enroll in and complete some of those online programs that exist. They're like MicroMasters or nano degree programs, and basically it takes about 6 to 8 months to complete those, and it's basically a crash program, a crash course, not a course because they cover different courses. And then my next video would be all about that. But basically there are different programs on becoming a robotic software engineer or becoming a self-driving car engineer on different platforms, Udacity, Coursera, and some of them are really good because they're taught by like top-notch engineers. So that's what you wanna basically enroll in and complete. And believe me, those courses or programs are good. As a matter of fact, to make sure that I'm telling people something that is backed by data. I looked at 60 LinkedIn profiles of robotic software engineers, specifically self-driving car engineers, to see like what was their background and how they became a self-driving car engineer. Like, did they take any online courses? Was their master's or PhD in robotics? And I found very interesting results, which I will share in my next video. So you may want to just subscribe and stay tuned. Hopefully, in next couple of weeks, I'll release that video. I had to go through a lot of resources. I had to review the Udacity 2 nanodegree programs. It took me a lot of time. I had to go through 60 LinkedIn profiles to find out the truth. So stay tuned, and I'm 8 minutes over the 30-minute time that was allocated to me. So thank you very much for your patience. I talk a lot, so thank you. So now I think it's time for question sync, right?
Yeah, yeah. Thanks a lot, Sina. That was really detailed and also, I think, very motivating because a lot of people joined today, and I think they would be interested in they are actually interested in starting to get engaged in robotics. So I think this would be very helpful. And so, yeah, let's move on to questions. And by the way, yeah. Do subscribe to Sina's channel. I think most of you would already know about his channel, Robotics with Sina. You could just search it and then you'd be able to find it easily. So yeah, let's move to questions, and just one point. Try to keep the question specific so that everyone has a chance to ask one question at least. So
Hello, am I audible?
hi, yeah, you're audible.
Yes.
Yeah, so yeah, my question was that there were so many terminologies used during your during this session. So can I find a list of the all the terms so that like I can learn them one by one, especially the physics ones? I mean,
Yes, definitely. Again, if you go to the description box of the video that I talked about, go to my channel. There's one, what do we call it, playlist, I believe. And then there, I listed all of these videos that I talked about, like the roadmaps, right? And then underneath in the description box, I have a step by step with all the resources. So just go there, you'll find all the resources, and it's been designed for people who want to follow a roadmap, and it's a comprehensive. It has all the resources, books, online courses, everything you need.
all
Yeah,
right, thank you very much.
Sure.
yeah. Thank you.
Yeah, I had two questions. Can I go?
Yeah, Krish. Yeah.
Yeah, so when you were talking about maths for like if you want to enter into software engineering for robotics, you did not mention calculus. Why is that?
Yeah. Hey, calculus is a must, right? If you're an engineer, you already
Oh,
know calculus. So so
acha.
it's just something that is definitely. Again, I did not get into very detail. I kind of start from the very beginning, but I thought because calculus is taught in high school as well, like where I grew up, and I don't know where you're from, but calculus is a must. They teach you. You already know about it. So that's why I did not mention it, but definitely is used. But the matter of fact is algebra is used a lot in robotics. That's why I emphasize it. And something people do not know is statistics is also used a lot. And like myself, I didn't know statistics is that important. I thought statistics is the people who major in math or they want to do data science, right? But the matter of fact is used a lot in what I do on a daily basis. Not a daily basis, but on a weekly basis, I use the statistics. A knowledge of statistics, even if you like, if you want to just work on other areas in engineering, statistics is a good thing to learn, even for life. Like, believe me, even your own life, statistics will help you.
Okay. Thanks. And my
Sure.
second question is, if like someone like me has a goal to learn C and C++ both in the coming future. So for me, I have like done a lot of Python in the past year. So if I am looking to learn C and C++, uh, which language should I start from?
So if you know Python, you're good. And C its own is a very like basic language. So if you know nothing and you start with C, you'll be fine too. So I don't think there is anything else you need to learn. And then again, like I said, it's C, C++, Python, and nice to know is MATLAB. So you already know Python. Start with maybe you can even start with C++ directly because you already know Python, and it's just not. And then you want to become a robotic software engineer, then C++ is a must. And then again, C++ is an extension of C. And like if you know C, then a lot of those syntaxes is used in C++, but C++ is an object-oriented programming. And believe me, it's a beast. It's probably one of the most difficult programming language to master. I still learn C++, like still like it's again there are a lot of advanced topics in C++ that it takes time to master, and it's just not taking a course or reading books, right? You have to use it in practice in your code. When you review different people codes and you still learn. As a matter of fact, a couple of days ago there was a bug in my code that took me 2 or 3 days to debug, and I realized that was maybe one of the basics, not very basic, like basics advanced, like one of the very basic things that people teach you when you take an advanced course that somebody just missed, and that was causing the code to crash, right? And again, you don't realize it until you use it in practice because all of those courses that, for example, they teach you what a class is, what an struct is, a structure or struct is, but they don't teach you like when to use a class, when to use a struct, right? And in practice, that's where you need to decide if you're doing a code, if you're coding for I don't know, like a real project, then you say, okay, do I use a struct here? Do you use a class here? What's the real difference in terms of application? And it's the same situation for other stuff that you learn in C++, right? So again, it's a beast. It's probably one of the most difficult languages to master, but if you master it, man, you'll be golden.
Yeah, that is a pretty nice answer. Thank you so much.
Sure.
Yeah, thank you, Sina, and thanks, Krish, for your question. So, yeah,
Um, Hi, Sina, Akash here. I had a question.
Sure.
Yeah, I wanted to
I like the
ask.
profile picture, man. What is it?
It's Barney Stinson from How I Met Your Mother. I don't know if you have watched the series or not, but
Yes,
he's a
yes,
pretty
I
cool
watched
guy.
that. Yes, I like that show. All right,
Yeah.
come on.
What my question was that for a person who is starting with robotics, what are few of the robotics self projects or group projects that you would recommend to build a very solid CV while clearing your concepts about robotics?
Very good question. Yeah, so it depends on whether you want to become a robotics mechanical engineer or robotics software engineer, electrical engineers. But overall, there are a couple of projects that I'm going to mention and think you can build up, like you can add to it. But a very good project that you can do is building a self-balancing robot. With that, you're going to learn a lot. You're going to learn mechatronics. You're going to learn control. You're going to learn a little bit of maybe no, I don't think kinematics would be there, but it's a very basic like project. It's a little like it's not too advanced, but not too simple. But especially if you want to become a robotics mechanical engineer, that's a good project because it shows you're good with designing a robot, like you know SolidWorks, you know rapid prototyping, you know how to build a robot. Then it shows me that you know mechatronics, and you learn a lot of mechatronics because you have to use sensors and then motors, and then you have to like implement a PID controller, which you will learn a lot, right? It's a solid project to do, especially for people who want to become robotics mechanical or even electrical engineers, right? If you want to become a robotics software engineer, there are a ton of projects you can do, but basically any computer vision project will be a good project. Something I usually tell people to do is either to get a drone, a programmable drone, and start doing a project, maybe just a SLAM, like mapping, simultaneous mapping and localization, mapping even in your room or something, or get one of those robot car kits, add a camera to it, and then go to a tennis court and try to like detect tennis ball and maybe pick them, right? With that, you'll learn a lot as well. Like you learn a little bit of machine learning classifiers and training sets, stuff like that, and then you'll learn computer vision, and you can do it in C++ or Python, and that's a solid project that you can do to pick up some of those skills and put it on your resume.
Yeah.
Um, Thank you very
Yes.
much. Absolutely love the answer and the session. Yeah.
Sure, and think you can add to that because you
Yeah,
probably have more
basically,
experience there.
yeah, thanks for sharing that. I mean, basically, one of the things should be you should take a project that you want to do. So, are you interested more in building a drone, or are you more interested in the mobile robot side of things, or are you like more fascinated by robot manipulator arms? So you could buy those, like robot kits that are also related to robot manipulators, or just start building a small mobile robot, and then you could slowly build on that, right? You mentioned also visual slam. You could use different computer vision techniques and just enhance on that. So basically, I think you should focus on what you're interested in, and then choose a project accordingly, but just start. I mean, just choose one and start. So that would be just one addition.
So yes, if can I ask any question?
Yeah, yeah. Who is it, by the way?
I I'm Ashak.
Ah,
Ashak.
Ashok. Yeah. Okay, yeah, Ashok, go ahead.
Okay. Okay. Sina, you said in before the programming questions they teach us class and structures. Likewise, we know maths also very essentials for robotics. Calculates metrics likewise. So in our universities, they teach us calculus and matrices, but they don't tell us probably I'm enrolling instrumentation automation. I think it's something related to robotics, but they don't tell how the calculus and matrix is going to be applied. So they tell only for the exams questions. So I'm asking the question is how these calculus and mathematics going to be applied in mathematics, in which what are the topics, or how can do we know any resources to applied in if we are going to do any projects?
Yeah, that's an awesome question. So I'm gonna give you two examples. First is, and Sync, you know better than I do. But if you're doing any computer vision project, any image is a 3D matrix, right? Okay, so if you're doing computer vision, matrix is used a lot. Vectors and metrics, right? Again, any picture, any image is a matrix, is a 2D, a 3D matrix, but then you can convert it to a grayscale or a binary image, and then it becomes a 2D image, right? And then it's basically a 2D matrix or a 3D matrix. The other example is kinematics. If you're doing kinematics, forward, inverse, and coordinate system transformation, it's all metrics and vectors. Again, going from one joint to another joint to the tip of the robot, from the base to the tip, or going through different coordinate systems, it's all transformation. And transformations are matrices as well as vectors. And it's used a lot. So these are two examples for you. So to show that, yes, metrics and vectors are used a lot. And that's probably one reason MATLAB is used a lot, especially when it comes to proof of concepts, testing, development, and simulation.
Yeah, that's perfect. And that's also a very good question, right? Generally, like when you study calculus or all of these things, matrices, and in your school, you don't know like what cool stuff you can do with it. So I think this is something that the schools should probably say it that way, that hey, this might be a bit difficult to learn now, but hey, you could do these kinds of things in the future with that. And yeah, only when you learn, let's say for example, you take up a robotics course on kinematics and dynamics, then you see, hey, yeah, matrices are now something that are being used, and hey, yeah, now this is something that is actually being used to build something really interesting or cool. So yeah, I mean, yeah, that's a good question. That's a good question.
Milano, you have to have a question, man. I see your camera is on. You're smiling.
Yeah, actually, I have one. First of all, thanks for your motivating speech.
Where are you from?
But I'm from, I mean, I'm in Germany right now. I'm studying
Oh,
at
nice.
TU Munich,
Okay,
but
cool.
I'm from Azerbaijan.
Oh,
So
nice.
my
Nice.
origins.
Cool.
Yeah, so first of all, thanks for your nice speech.
Sure.
It really excited me.
Sure.
But sorry if this is now a bit off topic, but I'm also super curious about the surgical robots you're working with
Yes.
because doing
Yeah.
something like that, like building a surgical robot, it must not be only super time consuming, but also overwhelmingly hard. So you basically need a whole team with at least one expert in each engineering area. So my question is, how did you do that? And with how, I mean not only from a practical point of view, but also from a psychological point of view, since this is something which is, let's say, underestimated by a lot of people. So
I
what
see.
was the biggest challenge you were facing there?
Yeah, so this is one of those questions that I cannot probably talk about in details because a
Yeah.
lot of the stuff I do is confidential. And but I'm gonna give you a very high level answer, right? So you are right. Surgical robotics is a different beast because on top of all the other software or robotics engineering skills that you need to pick up, it's now two other skills. One of them is FDA processes, something we call a design control. Like surgical robotics are highly regulated by FDA. So, and then everything you do needs to be in compliance with FDA design control process. So that's one big part of it. The other big part is, so now you have to know some of those surgical procedures, right? So for example, I can say that in public. I've worked on two different projects so far. One of them was a robot for a spine surgery. The other one that I'm working on right now is for knee, right? Knee replacement. So spine surgery, again, it's you now you have to learn how those surgeons do like a spine surgeries, right? You need to understand and learn the terms they use. You need to understand anatomy. You need to understand the technical, like the procedure itself, right? And so that's challenging. That's a lot of learning, but it's also what makes it very enjoyable, right? Because you interface with surgeons, you go to cadaver labs. I've gone to several cadaver labs, and you, you test your robots on cadavers, right? And so it's fun because you interface with a lot of different disciplines like surgeon, nurses, doctors, clinical engineers, systems engineers, and the entire team, marketing, and everyone. And you're right, it's usually the projects we do. Uh, it requires a lot of different disciplines. So and people specialize, especially if you're working for a big company, right? If you're working still for a smaller company, then you may have to wear different hats. One day you will be a test engineer, one day you would be a robotics software engineer, one day you would be a robotics mechanical engineer. But big corporations, big companies, the teams are huge. There are many engineers working on that project, not even engineers, doctors, surgeons, clinical engineers, and marketing other people that you have to and regular, like what we call it, RA and quality people, because those people make sure that you follow all of those FDA design control processes. So you have to specialize. Usually, you have to specialize in one area if you're working on a big team, right? And so yeah, so it's challenging, and but again, the skills that we talked about, a lot of them are still applicable to surgical robotics. And I do a lot of algorithms these days, and for that, and again, because I'm basically a robotic software engineer, it's all of those good things: C++, data structures, design patterns on the toolbox, on the core skills for a software engineer. And on top of it, it's computer vision, it's mainly math, a lot of math, a lot of paper reading, computer vision, a little bit of, I won't call it Islam, but it's navigation, what we call it. In surgical robotics, we call it navigation. And the reason for this is when it comes to the operating room, you have different components, right? You have the patient on the bed, you have a robot, you have surgical tools, You have something we call it a camera, which tracks the surgical tools, it tracks the patient. You have either an X-ray or a CT, and you have to establish mathematical relationship between all of this. Like the robot needs to know where the plan was on the X-ray or the CT, and then be able to understand where that plan mathematically like maps to that patient. And then if the patient moves, then the robot needs to move, and then it's the accuracy or precision needs to be really small, right? So it's a challenge. The stuff we do is complex stuff. Believe me, it's very complex. And but it's what makes it enjoyable, right? Because it's a constant challenge. You need to learn almost every week, and it's challenging. You get challenged, and I truly enjoy what I do. It's not like a job to me. It's just something I enjoy doing. It doesn't feel like a work. I put on music, I drink coffee, and it's just enjoy doing it. It's just really truly enjoyable.
Yeah, you probably use visual markers for doing the mathematical calibration between camera and the CTs, right?
All right, so now it seems like you're from one of our competitors.
No, no, but I've actually covered a course in my
Just kidding.
university about that.
Yeah,
So
I'm sorry, I cannot talk about the details.
okay,
It's
no
all
problem.
confidential, and yeah, I'm sorry.
Yeah, sure, we understand that. Yeah. Yeah, but thanks. I think, yeah, a lot of people would probably also be interested in surgical robots. Actually, before we were planning to keep the talk on surgical robotics, but the most members of the community wanted like how to start learning robotics and so on. So, but
Right.
yeah,
And Nikhil,
yeah.
and I want to just say Nikhil has a very cute profile picture, but he did not ask any questions.
Oh, and maybe he has now a question.
Just kidding. I don't know if he has actually a question. But yeah, so thank you very much, guys, for tuning in. It's just it was nice that like maybe not a lot of people joined because you all got to ask your own questions, and it was a nice conversation. My last point or my 2 cents would be if you're a mechanical engineer, electrical engineer, civil engineer, or even a web developer, and your job is not fulfilling, you don't enjoy it, switch today and you'll thank me later. Switch today, pick up the skills. It's not going to take a lot of time. If you're committed, you spend 6 to 8 months, and then maybe if you have time, if you have a few $100s to spare, enroll in one of those online programs. There are many of them available, and then become a robotic software engineer. Your life will change, and for good.
Yeah, thanks a lot, Sina. It was really a pleasure to have you talk about robotics, how to start learning robotics, and answering all of these questions. And yeah, wish you all the best on your YouTube and also on your work in surgical robotics. And yeah, we'll stay in touch.
Definitely, absolutely. Thank you for having me today, Sink.
Thanks. Thank you.